Okay, welcome to probability review with discrete random variables. We're going to start with question 1. The discrete random variable follows a binomial distribution. Probability of success is 0.6 and n equals 12 trials. Now, first of all, we want to describe the conditions for a binomial experiment. Look for these in your notes. Just to make sure you have all of them, there should be 4 conditions. All right, let's jump right into part B. Find the probability that x equals 2. So that means exactly 2 successes out of 12. Now remember, your random variable x has 13 outcomes. 0, 1, 2, so on, all the way up to 12. That's actually 13 outcomes. We want just the probability of 2. So using our formula, that's 12, choose 2, times probability of success squared, right? 0.6 times 0.6, because there are 2 successes, times 0.4 to the 10th, y to the 10th. Well, if you have 2 successes, you're going to have 10 failures. These numbers always add up to your number of trials, 12. In addition, these 2 probabilities are complements. They have to add up to 1. So even they didn't tell us the probability of failure was 0.4, we knew it had to be that. Now you can also use your probability distribution function on a calculator. If you do that, you do a binomial probability function and you're going to get 0.00249. Now, in part C, this is the probability that x equals 0, or, so we add probability x equals 7. Now I went ahead and found both of those using binomial probability distribution function. This first one is 1.667 times 10 to the negative 5th, and the second one is 0.22703. Now when you add them together, you should get really close to the second probability, 2270, and it's going to be like 46667. So we're just going to put 7 there. All right, probability that x is at least 9. So that means probability that x is greater than or equal to 9 is 1 minus the probability that x is less than or equal to 8. When you calculate these probabilities, you use a cumulative distribution function. All right, went ahead and calculated this with the 1 minus, and we're going to get something really close to 2253. Probability x equals less than or equal to 3. That's just your cumulative distribution function. That should be 0.01527. Not very likely. Probability that x is greater than 7. That means probability that x is greater than or equal to 8, which is 1 minus the probability that x is less than or equal to 7. So again, we're going to do a cumulative distribution function with just this part, and we're going to subtract that from 1. Went ahead and found that already at 0.4382. Probability that x is greater than or equal to 4. That's 1 minus the probability that x is less than or equal to 3. 0.9847. All right, mu of x, your mean or your expected value, is n times p. That's 0.6 times 12, or 7.2, which means if you repeat this whole process, right, 12 trials, then another 12 trials, then another 12 trials, and you count your successes, in the long run, they will average to 7.2. Your variance is n times p times 1 minus p. That should be about 2.88. And your standard deviation, let's get rid of the squared, is the square root of that. In our case, that's 1.697. All right, if we want to interpret that in context, on average, we're about 1.7 away from our mean, 7.2. All right, moving on. Question 2. Our discrete random variable follows a geometric distribution. Notice all we have is a probability of success. There is not a fixed number of trials. So when you describe your conditions, they'll look like binomial, except there'll be no fixed trials. Probability that x equals 2. Well, remember, we're talking about our random variable. It can be 1, not 0, but 1, 2, 3, 4, so on. So what's the probability to get to exactly? So we have to have 1 failure and then 1 success, because we succeed on the second try. So 0.21. Probability that x is at least 4. It's greater than or equal to 4. That's 1 minus the probability that x is less than or equal to 3. So very similar to above, we're going to do a cumulative distribution function here, but it's going to be a geometric cumulative. So use one of your calculators, TI, it's called geom_CDF. Right, we do this distribution with the 1 minus, and I believe we get 0.2401. Probability that x is greater than 5 really means probability that x is at least 6, or 1 minus the probability that x is less than or equal to 5. Right? I think here we get 0.2253. Probability that x is greater than or equal to 3. 1 minus the probability that x is less than or equal to 2. Again, another cumulative here. With the 1 minus subtracted from 1 already, we get 0.01527. Not very likely. The mean, or expected value, is 1 over p. So 1 over 0.3 is 10/3. So in the long run, our first success will happen about the 3rd try. The standard deviation is the square root of the variance, so let's do the variance first. That should be 1 minus p over p squared. All right, calculated that. Let's see, we should get 0.7 over 0.3 squared. We'll do that real quick. 0.7 divided by, we should get about 7.7 repeating, and the standard deviation is the square root of that. Really close to 2.789. All right. If you have any questions, feel free to ask me on Monday. Thank you for watching me to page 1. Page 2 is coming soon. Goodbye.